Hi everyone, so I'm Nathalie Henry Riche. Just a little bit of about me. So I'm a researcher at Microsoft Research. I joined in 2009 and I have two beautiful kids. That's like my biggest achievement in those 5 years. And then I come from France, so here is my cute accent, where I did my PhD between France and Australia with Jean-Daniel Fekete. So what do I do? So I try to visualize complex data to help people understand them. In particular, data scientists, so actually neuroscience, for example, that try to understand complex systems, but also what I call data enthusiasts. So, everyone, the novice people who try to often make decisions, so from particular set of data. So fortunately, I put this slide so you guys can understand how I position myself compared to big data. And in fact, I really care about complexity. It doesn't necessarily need to be big. Doesn't mean that big data is not complex, but it's really that part that I'm interested in, like all of the different facets and the richness that you can find in the data. I'm going to give you one example of my core project right now, and it's with neuroscientists from the University of Washington. And what they're trying to do is identify patterns in functional brain connectivity networks, so from scans that people do, to detect degenerative disease like Alzheimer's disease. And I'm just going to give you an example, because when I talk about fMRI, people think, oh, volumes of data. But in fact, I work with really small data, but it's already very difficult to visualize. So you take the brain, and basically we care about 23 regions. So I've put them there. It's not much. And there are 4 different groupings. But those regions are actually connected together, so they're correlated from at one particular point. And they could be correlated from -1 to 1 connection. So they basically are connected with weights on their links. And the problem here is they're very connected, as you could see there. And also, it doesn't make sense to look at it at one point of time, because your brain is not going to achieve one particular thing in one fraction of a second. But it's more over the course of a time. And so in general, it's about 5-minute scan. You have about 300 of those. And you actually have to find patterns there that will tell you something. And it's not even one, so this would be like a scan for one person, but you imagine that you have multiple people, some of those that have, variation in a bunch of things. That's the kind of problem that I'm interested in. And I try to work closely with scientists to understand what is their problem, what is the tool they're using. Right now they're using a lot of stats. And how can I help them with visualization to identify those patterns they didn't even think to look for in the first place. Because once you know what you have to, once you have to know what to look for, then you don't need, you need just to run your statistical test. So the 2 challenges I'm tackling, the first one is this, so trying to identify pattern in complex data. In particular, I try to find patterns in multiple dynamic, multivariate weighted networks. And to give you an idea of what's researched there, so what we don't really know what to do. So multiple networks, I know Ben has done some work in that, but there's still some, lots of unclear point there. Dynamic, we don't know how to do. Multivariate, we have no clue. And weighted, we don't know. So all of that really are research questions. And so you imagine that even if we answer one of those underlying terms, in fact, the combination of both is still a problem. So yeah, good luck for me. Just to give you a quick example, so this is some, what if I ask you to compare those 2? What changed? Is there some increase in some connections? Is there a node that is less connected than the others? So to answer those questions, I tried to design novel visual encodings. But also, I really try to come up with novel interaction techniques. Because it's not about a nice static picture. It's about allowing people to manipulate their data, to have multiple views on them, so they can find something, but also make sure that this something is not an artifact of the visualization. The visualization is not one beautiful picture. It's being able to look at your data in multiple perspectives. And then once you have found those patterns, in fact, that's not it. You might find one pattern, but you have to actually make sense of those multiple ones. So make sense of this wealth of insights you might get. and then try to form some sort of compelling story. And you have to communicate that story very often. In fact, neuroscientists, even though they're trying to help people with their brain disease, well, they also have to publish their research and so communicate what they found. And I've also been more recently interested in that whole pipeline, from exploring the data to telling the story. And most researchers, in fact, focus on either exploring or either telling the story, so communicating with visualization. But I'm particularly interested into this middle ground here, where you have a bunch of insights and you still don't really know how to communicate it. All right, and so to end up, you guys asked me about my wish list, which, it's the first time I'm here. I didn't really know what you were expected, but this way I can relate on what, I spend my time doing that is not really pure research. The first one is the collaboration effort. So I need to really talk to those neuroscientists. In fact, it's been 3 years I've been discussing with them to really try to get into what is it that they're doing, what is the data they're having, and that effort could be help with some more benchmarks or some sort of help from you guys. All right.